So today I'm here to talk to you a little bit about PERRS, persons, and networks. And because we got a little less time than expected because of the African swine fever new program, I decided to not show you a picture of aborted cells today. And I think everybody here knows that PERRS is a thing in swine, so I'm going to skip that. We're going to jump right into the persons part. So why persons? Well, people are important for PERRS control and elimination inside a farm. We know that because we know that farms, even sometimes within the same system, sometimes the same farm, have different levels of success in controlling or eliminating PERRS from a herd. And this is just to illustrate this example. We have here a graph from Sanhuesa's work on the time to stability for PERRS. So what he's showing here is a different time to stability, so time for a farm to wean negative pigs for different farms within 6 different production systems. So we can see kind of the two extremes here. So some farms are really good at it. They reach stability sooner, so even less than 25 weeks. Some of them go over 100 weeks. So we know there is a huge difference in how successful farms are in controlling PERRS. And we know some of it is related to the pathogen structure of the farm and all of that, but also there seems to be a huge difference on how we manage disease inside farms and related to internal biosecurity. The issue is that we really don't have a way to directly measure biosecurity. How do we internally measure how good or bad a farm is doing? That's very complicated. But I would argue, and I'll present to you today one of the systems. So we are developing new tools to deal with that. And now maybe we can actually have more control, measure this over time, compare, and actually define what is risky movements internally in a farm, what are not okay movements, what are okay movements, and so on and so forth. On the other side, talking more about between farm transmission or how did my farm get infected, we have farms that are connected indirectly via a whole lot of things. For example, here I'm showing you how the indirect networks look like for different things. So this is just overall considering a lot of different service providers, such as truck transportation, feed transportation, goat, semen, boar, all of these networks. Here we have the feed network and the truck network. So basically what you see here is a bunch of circles of the same color. That means all of the farms that are indirectly sharing one or more of those service providers. So we know that there is a lot of connectedness between our farms nowadays. Well, how much connectedness? One work that we did using Ontario swine herds in the province of Ontario, Canada, showed that about 94% of participating farms for this specific study shared at least one of those service providers. So we are connected regardless of what we think. Okay, so how does that affect disease status? Yes, we also showed that farms that had more connections were more likely to be positive for PERRS. So yes, increasing your connectability, if you wish, also increases your chance to get diseases. Again, our big challenge is that, now what? Do we treat all of these indirect connections the same? Well, probably not. We know that some of them will be riskier than others. But again, we lack the ability to measure this over time, to measure this for different systems, and we need this as soon as possible, hopefully, so we can better focus our efforts. So today I wanted to talk about this project that we are doing together with Merck Animal Health. They came up with this Be Secure program that we are using for this specific project. The technology behind it was developed by PigChamp Europe, and they've been using that for over 3 years now in Europe. So basically, there's 2 components for this project. The first one is really focusing on people and internal movements inside farms. So I'm going to refer to that as the internal biosecurity portion of the project. Second part is related to external biosecurity. So that one is about the networks. So for the first part, our objectives, I'm going to show you some preliminary data today, pretty fresh. We were trying to measure and describe internal movements inside U.S. farrow-to-wean swine farms. We wanted to investigate whether an increase in risky movements or what we think are considered risky movements would be associated with production parameters of interest. For example, we were looking for the specific part of the study, pre-weaning mortality, as well as number of pigs weaned per liter. For the network part, we also are aiming to try and start describing some of these connections and external movements, and we are for now using one system in Ohio with over 20 farms and sites such as feed mill, etc. For the sake of time and because this is an ongoing project, for today I'm going to focus on this first part with the internal biosecurity. So how does this work? We have 3 farms currently participating in this project. 2 of them are located in Indiana and 1 of them is located in Iowa. They vary from 1,400 to 4,500 sows, and they have anywhere between 10 and 25 full-time and part-time workers working there. Our inclusion criteria, we selected our farms based on PERR history, so we were looking for farms that have problems with PERRs and are constantly trying to control and eliminate PERRs. We also needed them to comply with this project that I'm going to present. There's a few challenges with compliance in projects such as this one, but this was our inclusion criteria. This is just a map showing in the yellowish shades that's swine density in the U.S., and the X's represent an approximate location for our farms, just to show you that they are located in relatively high density of swine. So how does this system work? Well, the first thing we had to do is to make sure that internet services were optimized throughout all of these farms. So that meant a lot of routers, a lot of testing, but we could get that finally done. And then one of these devices was installed in each room. So basically these farms are being monitored per room. So every single farrowing room, the gestations, every door is being monitored. So we have these devices here on the wall that are connected to an energy source. And then basically this talks with these little beacons that are the size of a coin. And these beacons were individually distributed to farm personnel, and most of them are using them in a collar-like thingy or on their pockets. So basically every time a worker there is carrying a beacon, and each worker has their own beacon, whenever they enter a room and go near these devices, this beacon sends out a signal via Bluetooth so that they are detected in the room they are at. So this is is sent in real time to a database where we are capturing all of these movements that are happening in a daily basis. So every day, workers go to the farm, they put their beacon, and they just go on with their day normally. The other thing that we needed to do is we need to think about how do we characterize those movements. So we did sampling for PERRs inside of the farms, and we were not really doing any sampling to prove for negativity or anything like that, but we just wanted to have a basic idea on where PERRs was at. We did a lot of PCRs for that. So then we classified the movements. Basically, that was based on PERR status, age groups, and then what are known risk areas. For example, the loading areas would be a high-risk area. A movement was defined as a worker left one of the areas of the farm and went to a different area and stayed in the second area at least for 2 minutes. That was considered one movement. And then we classified them into risky and acceptable movements. So risky movements were movements that were directly from the nurseries or loading points or shipping points to any other rooms of the farm, so to any other farrowing rooms or gestation rooms. And acceptable movements would be if they were respecting disease status, so if they were going from a negative PERRS area to a positive PERRS area, that was considered an okay movement. Also taking into consideration age groups and then groups within the same area. So if they were going from one gestation area to another gestation area, that was also an acceptable movement. So what I'm going to show you today, as I said, this project is ongoing. We've collected about 6 months of data as of today, and we have another 6 months to go. I had 14 weeks that I could work with to show you some preliminary results. So that's the data you're going to see today. And that's for one of the farms only. We got their production data from PigChamp, and then we developed some statistical models. Basically, what we were trying to go for these models was, are the different types of movement and the number of these movements, are they a good predictor for pre-weaning mortality and for number of piglets weaned per liter? So those were our main outcomes we were interested on for now. So I'll start showing you some of our preliminary results. This is a graph with the weeks here on the x-axis and the number of movements on the y-axis, and it goes anywhere from 0 to about 1,500. And basically, for each one of these, the data points that are expressed here, they refer to the different types of movements in the farm. So you can see definitely there are some outliers here that are very high number of movements. And if you were to guess which one of these ones that would be, that's farrowing room to farrowing room movement. So that was the most frequent one that we could see. The other types of movements, they were anywhere between 10 to about 100 movements per week. So these are numbers that we kind of didn't have any idea before. For this specific farm, it was about 4,500 sows, but these numbers, at least I have never seen before. So it's kind of nice to start putting some measurements there. The second thing that I wanted to show you today is regarding acceptable movements. So just a reminder, acceptable movements are going from negative areas to positive areas, or following the order from younger pigs to older pigs. So here in the green line, this is showing the number of acceptable movements. And then on the black line, this is number of piglets weaned per liter. So what I wanted to point out here is that they tended to kind of follow each other. So if we have a decrease in the number of these acceptable or ideal movements, that tended to also follow a decrease in the number weaned per liter. And the interesting part here was that we saw kind of a 1 week decrease. So if you would see a decrease in these ideal good movements, we would see a decrease in the number weaned per liter in the week following that decrease in the movements. The second part was looking at the risky movements. So again, just reminding you, this would be considered any movement from the loading areas, shipment areas to other rooms, or from the nurseries to farrowings or gestation rooms. And here we are showing the number of risky movements in red and the pre-weaning mortality in the dark blue. And what we can see here is, again, those two lines kind of go together with each other. So as we decrease the number of risky movements, pre-weaning mortality also tended to decrease shortly following that. If we see here a kind of a steady increase on the number of risky movements, we saw that our pre-weaning mortality tended to increase as well. And we see kind of a similar trend here towards the end of the period that we were looking at. The other production parameter of interest that we looked was number of weaned pigs per liter. And just from taking a brief look at this graph, we can see that these lines are crossing each other a lot. So what we could see is that if we as we decrease the number of risky movements, that tended to increase our number of weaned per liter. And same thing here, going opposite. So if we increase the number of risky movement, that tended to decrease the number weaned per liter. So those were kind of interesting things to note for this one farm. We just had this data from this one farm for now in a limited number of weeks, but I think those associations are kind of interesting to describe. Because I am an epidemiologist, I like statistical models. So of course I was too tempted not to do them, and I did do them. I'm not going to bore you to death with all the details, but I wanted to summarize kind of the two main findings from these models. One of them was that an increase in the risky movements in a previous week increased the pre-weaning mortality in the next week by about 3%. And the other finding was that an increase in the risky movements tended to decrease the number of piglets per liter by about 0.37. So while we are doing this project, it does require a lot of compliance. As I told you, it does require that the workers remember to use this beacon to wear them during their work. So one of the things that we are trying to do while this is ongoing and before we really have any solid data is we're trying to provide them short-term values so that they can use the system as they want. So one of the things that we've been working, and this is coming straight from PigCham, they've developed all these reports for the producers, and we've been working through them with them, is one of the things is that they are getting these updated measures of their risky movements over time. So I'm sure you're familiar with graphs like this one. You've seen them before likely, but basically the green areas show the amount of safe movements. So for this is a pretty good farm, about 80% of their movements is considered safe. And then the red ones, they are the risky movements over time. So they can work together with their staff and show these graphs and see how they're doing as they implement some changes in the farm. Another thing that they've been having and enjoying is to look at specifically which kind of risky movements are they having and which ones maybe would be avoidable and the ones that they should focus on. So, for example, for our first kind of beginning stages, we saw that one of their fairing rooms was positive. So we could measure how many movements were going from that positive room to other fairing rooms that were testing negative, and both processing fluids and oral fluids. And we also could flag that there was some movements that were going from positive areas to supply rooms where other people were also going. So then that could potentially track pathogens. In this case, we're focusing on PRRS, but really any pathogen from positive areas to negative areas through this common supply room. So these are just some examples of how they've been using this data on their day-to-day decisions. Well, what about PRRS, right? The name of the presentation was PRRS, and PRRS was the main focus of this project originally. So we've been doing PRRS sampling as well. So this is just kind of a scheme of the 3 different farms, and red areas are the positive ones. And we can see that over time, all of these farms are trying to eliminate or control PRRS. So as expected, we are seeing an improvement in their PRRS in terms of reducing the amount of positive PCRs. So some take-home messages from this preliminary analysis for the study. We could see that this new type of tracking system could be doable for North American conditions. We also could see, based on this data, that an increase in risky internal movements was associated with a decrease in the number of weaned per liter and an increase in pre-weaning mortality. And as I talked to the veterinarians and the producers, this is not necessarily PRRS related, and we can't really tell that because we're not doing weekly PRRS sampling. But that could be really applicable to any pathogen. So one of the things that I heard is that these cowers come in and out, so they think that maybe some pathogens could have been carried from the loading docks and nurseries back to our fairing rooms, and that would result in some of the things we saw. Future steps, like I said, this is data from only one farm, a limited time period, so we want to get the data from the other farms and then have the whole year worth of movement data and see what we can find out, not only in regards to PRRS, but production data as well. And we also have the external movement data going, that part of the project, which is geofencing different farms and looking at external movements from production companies. So that's also coming up. With that, I'd like to acknowledge Merck Animal Health for their funding for this project, PigChamp Europe that has been facilitating anything from installation of the system to feedback and working with this very messy big data. I'd like to acknowledge the swine veterinarians that are working with me, if it wasn't for them, to help me recruit the farms as well as get the sampling done. This probably wouldn't have been where it is. And of course, the swine producers that are interested in learning with us as we continue with the project.